Welcome to the lectures on Chapter 4. For this chapter, I've broken up each lecture into a smaller, shorter video. Hopefully this will help if you need to go back and review. Enjoy these. A force is a change in motion. It's any push or pull between objects that can cause the motion to change. It basically causes an acceleration. It's the change in velocity. Most of the forces that we will look at or see on a daily basis are contact forces between two people pushing on each other, you pushing a chair in, something like that. That's two objects are touching. Non-contact forces, for example, would be the force of gravity. The two masses, in this case, do not have to be touching to experience a force. Chemists define mass as the number of molecules in a given substance. They count how many atoms, electrons, neutrons, protons, etc. And that is how they view mass. Physicists, on the other hand, view mass as the measure of inertia. Inertia is the resistance to a change in motion. The more mass you have, the easier it is to resist a change in motion. So this is a really key idea within physics, that mass is the measure of inertia. It's very different than weight. Weight itself is a force. It's completely different than mass. So it's very important to understand the separation between the two. We will talk about this more later on in other lectures for this chapter. If you think of a net from a fishing standpoint, it's something big that just dropped into the ocean to collect as many fish as possible, or pull up all the total fish in the area. When we look at forces, the net force is all the forces, or the total force, acting on an object. In order to do this, you use vector addition to add the forces together. We'll look at this more closely in other lectures and how to split them off into components, which you should already be pretty comfortable doing with vectors. But just once again, the net force is the total force, or the sum of all forces acting on an object. I believe that most of you are probably already familiar with Newton's first law of motion. It's also sometimes called the law of inertia, because inertia is the resistance to a change in motion. Under Newton's first law, an object at rest will stay at rest. An object in motion will remain in motion at a constant velocity. This is important because velocity includes speed and direction, unless acted on by a net outside force. And as I just mentioned, a net is the sum of all the forces acting. So a net outside force. Once again, inertia is the resistance to a change in motion. And as we said, it's measured by mass. The more mass you have, the more that you're going to want to remain doing what you're doing. So think of pushing a big giant elephant as pushing a tiny little mouse. Elephant has a lot of mass, so it takes a much greater force to move that elephant, whereas the mouse has a much smaller mass, so it takes much less force to change the motion of that mouse. As we move on here, we're going to be looking at what the net force is on the object and how that relates to the motion of some object. In this case, if the net force on them is 0, that means that its acceleration, therefore, must be 0. So that way, the velocity is going to be constant. This is an important idea to make sure you remember as we're going forward. A constant velocity for an object if the net force is 0. Thank you very much for watching this. Please make sure to follow along in this textbook and make sure you read each section thoroughly. Have a good afternoon.